Greetings to all. Myself Vaishnavi, Assistant Professor, IT Department from SNS College of Engineering. Now we are going to see about the multiprocessor scheduling and real-time scheduling in algorithm evaluations. First one is multiple processor scheduling. It consists of more than one processor, that is multiple CPUs shared the load, that is load sharing in multiprocessor scheduling, so that the various processes can run simultaneously. It shares the common bus, memory and other peripheral devices. So we can say that the system is tightly coupled. Next point, these systems are used when we want to process a bulk amount of data, and these systems are mainly used in the satellite, weather forecasting and etc. Next one is multiple processor scheduling. The multiprocessor systems may be heterogeneous, that is different kinds of CPUs, other homogeneous, that is same CPUs. There are the two approaches of multiple processor scheduling in the operating system, that is symmetric multiprocessing and asymmetric multiprocessing. Next one, symmetric multiprocessing. It is used where each process is self-scheduling and all the processes may be in a common ready queue, or each processor may have its private queue for the ready processes. The scheduling proceeds further by having the scheduler for each processor examine the ready queue and select the process to execute. It comes under the symmetric multiprocessing. And for the asymmetric multiprocessing, it is used when all the scheduling decisions and the input output processings are handled by the single processor, that is we defined as the master server. Next one, the other processor execute only the user code. Third one, this is simple and reduce the need for data sharing, and the scenario is called the asymmetric multiprocessing. Next one, real-time scheduling. The real-time computing is divided into two parts, that is hard real-time systems and the soft real-time systems. First one, hard real-time systems. The hard real-time systems are required to complete the critical task within the guaranteed amount of time, and the scheduler requires a process to declare its deadline requirements before entering into the systems. And then it employs a technique known as an admission control, that is the process is admitted if the scheduler can ensure that it will be accomplished by its deadline, otherwise it is rejected. Next one, soft real-time system. The requirements are the less strict. It is not mandatory to meet the deadline. The real-time process always gets its priority over the other task and retains the priority until its completion. Next one, the implementation of the soft real-time system requires the following properties. First one, must employ the primitive property based scheduling. Second one, real-time processes must be assigned higher priority than non-real-time process. Third one, priority must not change during its lifetime. Fourth one, dispatch latency must be the low. Next one way to keep the dispatch latency low is to provide the preemptive kernels, which allows the presumption of a process running in the kernel mode. Next one, priority inversions is a problem that occurs when the higher priority process requires accessing the kernel data currently being accessed by the some low priority process. So the higher priority process has to wait for the lower priority to complete their executions. The priority inversion problem can be overcome using the priority inheritance protocol. This protocol allows the lower priority process to inherit the higher priority when they are done with the resources, when they are finished their process and reverts to the original value. Algorithm evaluation. To select an algorithm, we must include the several measures such as maximize the CPU utilization under the constraint that the maximum response time is 1 second, and maximize the throughput such as the turnaround time is linearly proportional to the total execution time. Next one, different evaluation methods are first one is deterministic modeling, that is one major class of evaluation methods are called the analytic evaluation. Analytic algorithm uses the given algorithm and the system workload to produce a formula, and the number of evaluates the performance of the algorithm for that workload. One type of analytic evaluation is deterministic modeling. This method takes a particular predefined workload and defines the performance of each algorithm for that low workload. Next one is queuing model, that n is equal to lambda into w. Here n defined as the average queue length and w is the average waiting time, and lambda is the average arrival rate. This equation is called as the little formula. Third one is simulation. It is more accurate. Simulation involves the programming of the model of the computer systems, and the trace tape is created by monitoring the real systems, recording the sequence of the actual events. Fourth one is the implementation. The only completely accurate way to evaluate the scheduling algorithm is to code it, put it to the operating system and see how it works. The major difficulty is the cost of these approaches. A form of this method is used commonly for the new computer installations. Thank you.